the title of my project, Global Warming Mitigation, Optimizing CO2 Removal by Algae Farming. Global warming is one of the biggest problems that we currently face, and it's caused by an excessive amount of carbon dioxide in the air. One of the best ways that nature can get rid of CO2 in the air is through photosynthesis. Algae, more than any other photosynthetic organism, is responsible for taking CO2 out of the atmosphere. In recent years, there's been a lot of research to find the to optimize algae growth and to combat climate change. Some of the things that have been tested on include pH, light intensity, and nutrient level, but I couldn't find anything about a light-dark cycle. So the question of this experiment is, what is the optimal light-dark cycle for nanocalypsis, the algae I'm going to test? Now, the basic hypothesis would be that, like everybody says, the best cycle time will be 12 hours on, 12 hours off, like it's been for algae for over 3 billion years. So that was also the hypothesis. In every 16-ounce mason jar, there's the same amount of nutrients, salts, nanocalypsis, and water. Each of these 8 different jars can have a different duty cycle and period. The jar on the left is the one that's always on, and the jar on the right is the one that's on, which is never on. In the middle, there are different jars that have different duty cycles and cycle times. This first chart shows the growth in the first 8 days. As you can see, the blue, which is always on, performs significantly better than when it's on for 16 hours or when it's on for 12 hours. The one that's always off is the control. The second graph shows the average algae growth per day for the first 7 days. So when it's always on, it works the best, as shown in this experiment, but every single other jar performs better than when it was on for 12 hours and off for 12 hours. So when jars have the same duty cycle, they're on for the same amount of time. The only difference is the amount of continuous light exposure that they get. Jar number 2, which had 16 hours on and 8 hours off, performed considerably better than when it would be on for 8 hours or off for 4 hours, for example. The life cycle of algae is shown here. In the first stage is the lag and exponential phase. You see it get to its very peak, the stationary phase, which is usually when people harvest, and then you see it die. At the beginning of the stationary phase, that is when people usually harvest, and that was on day 9 for the algae that had a light that was always on. When the light was on for 12 hours, the harvest only happened 4 days later, and the peak only happened 9 whole days after the harvest for the always on. So this shows that the more continuous light exposure that nanocalypsis has, the more it will grow. It also shows that nanocalypsis does not need a dark cycle.